Hello guys, we continue our discussions with number 9, quiz 6. Okay, number 9 diagram shows the hydraulic pump lifting a car in the workshop. So I have an air compressor. Okay, inside here we have compressed air. This compressed air will be pushing the oil, okay, into the system, and it will lift the piston up, and in turn the car will be lifted. Alright, let's go to the question. Name the physics principle that is used in hydraulic pump. Okay, so I have a liquid enclosed. Okay, I have oil enclosed in the system, and I also have compressed air also enclosed. So what physics principle is this? This is Pascal's principle. Okay, next, state an important characteristics in using oil. Okay, inside here we notice that the system is using oil. What is so special about oil? Okay, remember that the liquid that we use in a hydraulic system, it needs to be something that is incompressible. Okay, so one of the important characteristics of using oil would be oil is incompressible. Okay, meaning that the oil is not easily compressed. Okay, B1. The pressure of compressed air is 5,000 Newton per square meter, and the area of the piston's cross-section is 2 meters square. So what is the pressure of the oil in the cylinder? Alright, so what we have here, we have the pressure, and then we have the area. And we want to know the pressure in the cylinder. Okay, so remember what Pascal said? Pascal said that in an enclosed system, okay, enclosed system, the pressure will be distributed equally throughout, uniformly throughout. So if the air compressor provide 5,000 Newton per square meter of pressure, then the pressure of the oil in the cylinder will definitely be 5,000 Newton per square meter as well. Okay, that's what Pascal said. Remember, in an enclosed system, okay, the system is closed, the liquid inside it will have the same pressure throughout. Okay, we continue with B2. Calculate the maximum mass of load which can be lifted by the piston. Okay, so remember that our pressure P equal to force over area. And bear in mind that the force is perpendicular to the area. You can only use the perpendicular force with respect to the area of contact. So the pressure is given 5,000. Okay, and then the force, do we have the force given? Remember that force can be calculated in terms of weight. Weight equals to mg. Okay, so what is our m? Okay, m is something that we need to find out. See here, calculate the maximum mass. Okay, g will be 10. So here I have 10 m. Okay, so F equals to 10 m, and then we divide by the area. Area is 2 meter. So calculate M, you should be able to get 1000 kilogram. So that is the maximum mass of load which can be lifted by the piston. Okay, let's go to the next question. What modification that need to be done on the piston and the cylinder so that it can lift heavier load? Okay, the objective is to lift heavier load, and you are to make modification on the piston and the cylinder. Okay, let's see. From P equals to F over A. Okay, then F is equals to PA. Alright, so heavier load. So I want to make my F to increase. What choice do I have? What can I do? Okay, I can increase the pressure. Okay, I can increase the pressure, or I can increase the area of the piston. Okay, so what modification can you make? Okay, one, okay, we can increase the cross-sectional area of the piston. Okay, so that we can lift heavier load. Okay, that is area. Now, can we increase the pressure? Yes, we can increase the pressure, but we need to work on what modification that we are going to do to the piston and the cylinder. Okay, so here I have done something to my piston. Okay, what about the cylinder? Okay, well, the cylinder, we can also increase the cross-sectional area. Okay, we deal with the area, so it's we're done with it. So what can I do about this pressure? Okay, so if I increase the pressure, so what happened? Okay, one thing that might happen, okay, the wall of the cylinder, it may break. So we don't want that to happen. So what do? We increase the thickness of the wall. Okay, the thickness of the wall of the cylinder. Okay, why do we do this? Okay, so that it can withstand high pressure. Okay, otherwise the cylinder will collapse. So we don't want that to happen. So these are the two modifications that we can make onto the piston and the cylinder so that the system can lift heavier load. Okay, do you get it? Alright, let's move on to the next question. Now we are given a cross-sectional area of a hydraulic jack used to raise a load, and we have force F1 applied to the top of piston 1. So I have P1 here on piston 1. The cross-sectional area is 1 centimeter square, and then on piston 2, okay, so this piston 2 will be going up. It will lift the load up, and the area here is given 80 centimeter square. Okay, so what principle is this? So I have liquid in an enclosed system. The pressure is distributed uniformly throughout. Okay, so this must be Pascal principles. So from what Pascal's say, then the pressure at piston 1 must equal to the pressure at piston 2. Okay, and remember that pressure equals force divided by area. Okay, let's answer the question. Compare the surface area of piston 1 and piston 2. Okay, this is easy question, just comparing. Alright, so how do we answer this? Alright, so you must write down the quantity that are to be compared. So here the quantity is the surface area. Okay, so we write surface area of which one? Okay, let's say piston 1 is smaller, right? Is less than the surface area of piston 1. Okay, so I just write here the surface area of piston 1 is smaller than that of piston 2. Okay, next compare the forces F1 and F2. Okay, so just by looking at the diagram, I do know that F1, okay, F1 must be smaller than F2. Because here I have small load, here I have a bigger load. So definitely force, okay, remember, write down the quantity to be compared. So the force, okay, force F1 is smaller than force F2. Simple, right? Okay, next compare the pressure exerted on the piston. Okay, so what do I know about pressure in Pascal principle? It says that pressure is the same throughout, right? So the quantity to be compared is pressure. So what about the pressure? Pressure is the same, or pressure is equal. Alright. Next, relate the surface area and the force produced on piston 2. Okay, so this question specifically mentioned on piston 2. Okay, so on piston 2, if I go back to my answer A and B, because we are looking at the surface area and the force, right? So I have here surface area and the force. Okay, so what do I know about piston 2 compared to piston 1? Okay, piston 2, the surface area is larger, correct? So here the surface area for piston 2 is larger, and then F1 compared to F2 again. Okay, here is A2. Okay, here I do know that F2 is greater. You see here, greater, greater. If I look at my piston 1, okay, piston 1, my A1 is smaller, correct? And then my force 1 is also smaller. Okay, do you follow? Alright, so let's answer the question. Now, you are to relate the surface area and the force produced on piston 2. So, the higher the surface area, the higher the force. Okay? Or, the smaller the surface area, the smaller the force. Okay, do you get it? Okay, now, so let's answer this question. So since the question asks us to look at piston 2, so I am going to write here the higher the surface area, the higher the force. Okay, or as surface area increases, the force increases. Same thing. Okay, now let's move to the last sub questions of question number 10. Name one other device that uses the same physics principle. So one other device would be our hydraulic brake. Hydraulic brake. Okay, so that is question 10. Now, let's move to question 11. An efficient hydraulic brake system is very important in a car for safety purposes. Diagram shows a car hydraulic brake system. So I have a man's foot here pressing on the pedal. So what happened? It will push the piston, okay, inward, okay, towards the piping here, and it will push the liquid, the our brake liquid here, the brake fluid, okay, to move about. Okay, it actually what's moving is the pressure. All right. Suggest and explain the modification that should be done on the system so that it can function effectively based on the following aspect. Okay, so objective is function effectively. Okay, that is the objective of modification. Okay, the type of substance for the brake fluid. So what type of substance that you can use as the brake fluid? Okay, so here we use incompressible fluid. Okay, example of incompressible fluids, okay, would be such as oil. Okay, so this is the suggestion. So use incompressible fluid. But what's your reason? Okay, so that this is our reason, so that the pressure is transmitted okay uniformly and effectively. Oops. Uniformly and effectively. Okay, and then the characteristics of the brake fluid other than being incompressible. Okay, so I need it to have high density. Okay, or high viscosity. Okay, viscosity in bahasa Melayu is kelikatan. Okay, why do you need to use high density or high viscosity? The reason is so that it doesn't evaporate easily. That's the reason. Okay. Now, C. The cross-sectional area of the output piston. So the area of the output piston, okay, remember that from our P equal to F over A. Okay, therefore F equals to PA. So I want this force to be big, then the area must be big. Okay, so the cross-sectional area of the output piston, it must be big. Why? Okay, so that greater output force, okay, greater output force on the piston can be produced. Okay, and what about the cross-sectional area of the input piston? So for input piston, you need something that you can press more easily, right? Therefore, the area of the input piston, it must be small, right? So here, the cross-sectional area of the input piston, I will choose small one. Okay, reason is to produce greater pressure when the brake pedal is pressed. Okay, so this one is from pressure equals force over area. So when I decrease my area, then my pressure will increase, right? And at the same time, of course, it will be easier to press the pedal. You don't need to use too much effort pressing the pedal. Okay, E. One other safety measure in hydraulic brake system. So here it talk about a safety measure. So what is the safety measure that need to be installed in hydraulic brake system? So one, okay, I would like that the pipe, which we call as the distribution pipe, is made of steel. Okay, why do we use steel? What is so special about steel? Because steel doesn't rust easily, right? So uh, the one of the safety measures, one is distributing the distribution pipe is made of steel, so that okay it won't rust easily. Okay. Other than that, we know that steel is a strong material. So one of the reasons why we use distribution pipe made of steel would be it can withstand high pressure. Okay. So is there any other safety measures that we need to take into account in the hydraulic brake system? Okay. We have to make sure that we get rid of air bubbles. Okay. So what is bad about these air bubbles? Okay, why you must get rid of air bubbles? Okay, because if you have air bubbles, then the pressure that you produce, it will be used to compress these air bubbles. Hence, the pressure will not be transmitted effectively. Alright, so get rid of air bubbles. Okay, so that force will not be used to compress the air bubbles. Okay, do you follow? Okay, you can also say get rid of air bubbles so that pressure can be transmitted uniformly and effectively. Alright, so these are two safety measures that you can install, that you can make sure in a hydraulic brake system. Alright, let's move to question 12 now. So diagram shows a cargo ship with plimsoll lines is sailing in seawater. Name the physics principles involved which make the ship float in seawater. Alright, so the ship floats because of there is what we call as the buoyant force. Well, definitely the ship, it will have a force going down, that is the weight of the ship. Alright, the weight of the ship. Okay, now in dealing with this buoyant force, okay, we are actually dealing with what principle? Okay, so this is our Archimedes. Archimedes principle. The plimsoll lines marked at the side of the ship state the purpose of the plimsoll line. Okay, so what is the purpose of the plimsoll line? That is to ensure the ship is not overloaded. Is not overload. Okay, because different seawater will have different density. Okay, so this is the purpose of having the plimsoll line mark at the sides of the ship. Okay, C. A researcher in a ship manufacturing company. Okay, so you are assigned to study the structure used to make the ship to support heavy cargoes. So you are given 4 choices of structure: W, X, Y, and Z. And the table below shows the structure of the boat. Okay, and then explain the suitable characteristic of the structure to be used to make the ship. Determine the most suitable structure for a ship capable of carrying heavy load. Give reason for your choice. So what is the objective of this selection? Okay, the objective is can carry heavy load. So that is the objective. All right, so how do we answer this? Okay, so it's better for us to draw table, okay, with 3 columns. The first column for aspect, the second column for our selection, our choice, and the third column is for the explanations or the reason, okay, for choosing the selection. So for the aspect, just copy it from the table. Okay, so I have 4 aspects to be inspected. I have shape, okay, and then the total mass of the ship base width, and then the volume of the air space in the ship. All right, so just copy it down here into our aspect column. So I have the shape, okay. Next, I have total mass, of the ship, and then next I have the ship base width, and lastly is the volume of airspace in the shape. Alright, so let's look first at the shape. So what type of shape are you going to choose? So here, okay, under shape, I only have two choices. It's either streamline or oval. So for a shape, what type of shape are you going to choose? Okay, so a better design would be streamline. Why do we choose streamline? Okay, this is to reduce water resistance. Okay, next, the total mass of the ship. So definitely I want to have a lower mass. Okay, so here I have 7560, 7900. So here I have four choices. So you are not going to just simply choose one number. Okay, since you have four choices, then you need to use terms like high, low, or moderate. So in this case, we are going to choose low. Okay, why do we choose low mass of ship? Okay, simple reason. This is to reduce the inertia effect. Okay, remember that in inertia, heavier object will be more difficult to move and also will be more difficult to be stopped. Okay, so for the ship is a very huge object, okay, with very high mass. So we need the ship to be able to move more easily and at the same time to be able to stop more easily. Alright, so that's why we choose a ship with low total mass. Okay, next, the ship base width. Okay, here we also have four choices. So remember that we are not going to choose any number. Okay, since we have four choices here, so it's better to use terms like high, low, and moderate. So for the base, what type of base are you going to choose? Okay, so here I'm going to choose high. Right? So why do I choose a wider base? Simple reason, it is more stable. Okay, so we don't want the ship to be overturned. Alright, next, volume of the air space in the ship. Okay, this is the air space. So here we have two choices, low and also high. So which one do you choose? Okay, so here we are going to choose high. Alright, so why do we choose high volume of the airspace? This will produce greater buoyant force. Okay, so we have fill up the table. Okay, so now let's go back to the original table and we mark the characteristic that we have chosen. For shape we choose streamline. Okay, so streamline, I tick streamline. And then low, so for low I'm going to choose two low total mass. Okay, the two lowest total mass would be 5550 and 5510. For the ship base width we choose high, so we are going to choose two width that is higher, that will be 55 and 57. And then for the volume of airspace we choose high. Okay, so for high I mark high here. Okay, here is also high, so I mark it here. And next we count how many tick. So for W, I have 3 ticks. Correct? 1, 2, 3. For X, I have none. For Y, I have 3. For Z, I have 2. Okay, so you see here, the most tick, we have two choices also. We have W and also Y. So you have to make a wise decision. Okay, which one are you going to choose? Are you going to choose W or are you going to choose Y? Remember that we want the ship to be able to carry heavy loads. Alright, if the total mass of the ship is already heavy, so what can you say about the load that it can carry? So definitely the load that it can carry would be less heavier. Okay, do you follow me? Alright, so if that is the case, then I am going to choose Y, because the total mass of the ship is 5550, so I can put more load. Okay, I can put more load into this ship. Okay, follow? Alright, so the most suitable structure would be Y. Right, and why do we choose Y? We repeat our selections, which we combine with the aspect. So why we choose Y? Because it has streamline shape. Okay, and the next is low total mass of the ship. Okay, comma. Next is high ship base width. Okay, so just copy it down. High ship base width. Okay, and lastly, high volume of air space in the ship. Okay, so just copy it down here for the reason. So high volume of air space in the ship. Okay, so we're done with question 12. You see how easy we answer the question? Sometimes you can goreng-goreng lah, but make sure when you goreng, it tastes good. Alright, now let's move to question number 13. Okay, diagram shows a load X is placed on a wooden block. Both of them are then placed in water of density 1000 kg per cubic meter. The mass of this wooden block is 2.5 kg and the density of this wooden block is 550 kg per cubic meter. Okay, so we have a few information from the question. The density of the water, okay, the density of the water is 1000, okay, kilogram per cubic meter. And then the wooden block, the mass of the wooden block, okay, mass of the block is 2.5 kilogram. And then the density of the wooden block is given 550 kilogram per cubic meter. Okay, now calculate the volume of water displaced by the load and the wooden block. So how are we going to calculate the volume of water displaced? Well, it's common sense. Alright, so I have this wooden block immersed, okay, completely under the water, so the volume of this wooden block must equal to the volume of the water displaced. Alright? So the volume of water displaced must equals to the volume of the wooden block, okay, under the water. How are we going to find the volume of the wooden block? Since the wooden block is totally under the water, right? Okay, so I hope that you notice that. So how are we going to find the volume? Well, why are you given the density? Okay, so the density equals mass over volume. So you see here, for this wooden block, I know my density, I know my mass, so can I find the volume of the block? Yes, alright. So the volume of the block equals mass divided by the density of the block. Alright, do you follow? So the volume of the block equal to the mass of the block divided by the density of the block. Alright, so here mass of the block divided by the density of the block. The mass of the block is 2.5 kilogram divided by the density is 550. Okay, just calculate it. You should be able to get 4.55 times 10 to the power of negative 3 cubic meter. Okay, so the volume of water displaced is equal to the volume of the wooden block under the water. Alright, next, calculate the mass of load X. So, before we answer this question, we need to understand first that this is something to do with Archimedes' principle, right? Because here we do have buoyant force. So I have a force going down, that would be the weight. And I have a force going up, that would be the buoyant force. Okay? And I do know that this thing is floating, it's not going down, okay, it's not sinking, it stay there. Then this W, the weight, okay, must equal to the buoyant force. Okay, but what weight? The weight of the wooden block plus the weight of load X. Alright, so this W is actually equals to the weight of the wooden block plus the weight of load X. Alright, can you follow? Alright, so I am going to rewrite it here. So the buoyant force equals to the weight of X, okay, load X, plus the weight of the wooden block. Okay, what else? Okay, what else does Archimedes say is about this buoyant force? The buoyant force is also equals to the weight of water displaced. Alright, so that's what Archimedes say, right? Okay, try to digest that information first. Make sure you understand what we are talking about. Okay, so do we know the weight of the water displaced? So if I go up for the water displaced, okay, for the water, I know that I am given the density of water. So there must be a purpose. There must be a reason why we are given the density of water. Alright, so I'm going to write here the density of water, density equal to mass of the water divided by the volume of the water displaced. Right, so the density of the water is 1000 equal to the mass. We don't know the mass. We are going to find the mass. And the volume of the water displaced is calculated in the previous question. That will be 4.55 times 10 to the power of negative 3. Alright, so calculate our mass of water displaced. So if you do this calculation, you should be able to get 4.55 kilogram. So I have the mass of water. So can I now find my weight of water displaced? Can, right? Okay, so my weight of water displaced equals to the mass of the water displaced multiplied by the gravitational acceleration. So here we have 4.55 multiplied by 10. So you will end up with 45.5 Newton. So this is the weight of the water displaced. Alright, so let us go back to this equation here. So what is Wx equals to? That would be mass of x multiplied by the gravity. Correct? And then the weight of the wooden block, that would be the mass of the wooden block multiplied by the gravity, equals to the weight of the water displaced. Okay, we have just calculated it just now, and it happened to be 45.5 Newton. Alright, so we don't know the mass of load x, right? That is what we are supposed to find out, right? But g is 10. So here I'm going to write this as 10 multiplied by mass of x, okay, plus, and then the mass of the wooden block is given in the question. It's 2.5 kilogram multiplied by the gravity 10, okay, equals 45.5. So now can you find what mx is? Yes, very straightforward now. Okay, so your mx, the mass of load x, if you do your calculation correctly, you should be able to get the answer is 2.05 kilogram. So that is the mass of load x. Alright, make sure you understand what we are doing here. Okay, let us move on to question 14. Barry stands near the rail at a LRT station. When the fast train passes in front of her, she experiences a force that pulls her toward the rail. Okay, so experiences a force that pulls her toward the rail, meaning to say that if this is Betty, okay, there must be something that is pushing Betty toward the train. And I do know that in between here I have air flowing, air is moving. So what principle is this? Okay, so we have movements of fluid, so that would be the Bernoulli principle. Okay, now diagram shows two similar ping pong balls suspended on strings of the same length. What will happen if air is blown with high speed between the two balls, and explain why. So I have air blown in between here, so my velocity would be high. So what does Bernoulli say about this thing? If the velocity is high, then the pressure must be low. Okay, but outside here I don't have anything moving. Okay, so outside here I only have my P atmospheric. Here I also have my P atmospheric. And what do I know about this atmospheric pressure? It is higher. Okay, the atmospheric pressure is higher than the pressure inside here. So there is nothing moving outside here. So here I have air being blown, so the velocity of air will be very high, and this will produce a very low pressure region in between. So what happened? The ball will be pushed inward. Okay, can you follow? All right, so if you can follow, so you can write your answer. Okay, so I will just write the answer here. What will happen? So the balls move toward each other. That is what is going to happen. All right, next is you have to explain. So this is our explanation. Okay, so that is our explanation. Okay, already. So let's move to the next questions. Oops, this is supposed to be question number 16. Number 16, and this is supposed to be question number 17. Sorry for that. Okay, diagram shows the roof of a house being lifted by strong winds. Name the principle involved. Okay, so I have a moving fluid. Okay, air is moving, producing high velocity, and then high velocity, then high velocity, it must come with low pressure. So what principle is this? Just like before, This is the Bernoulli principle. Okay, using the concept of force and pressure, explain why the roof is lifted when the roof is blown by strong winds. Alright, so we are going to repeat what we have mentioned before this in question number 15. So there's nothing new here. So the velocity of the air on top of the roof is high. Okay, so the velocity of the air on top is high. So what happened? Okay, so this, sorry. So I erase this first. Okay, this creates or this produces, okay, low pressure or lower pressure, okay, on top of the roof. The pressure inside the house is lower, sorry, is greater, not lower, or higher. Okay, so the pressure inside the house is greater. Okay, why is greater? Because the velocity of air inside the house is smaller, hence the pressure is greater. All right, so the pressure inside the house here is greater, the pressure on top of the roof is smaller. So what happened? I have a difference in the pressure. All right, so the net pressure will be going up. P up is greater than P down, so P up will win, right? So the pressure inside the house is greater, hence the difference in pressure okay create resultant force or produce resultant force that lift the roof. Okay, so it's due to the difference in the pressure. This will in turn will create a resultant force, and this resultant force will lift the roof. Okay, so try to understand the concept there. Right. So we move on to the last question. Finally, the last question. Table shows the design for aircraft P, Q, R, and S. You as an engineer are required to determine the most suitable aircraft which can fly the fastest. Okay, study the specifications of all the four aircraft and determine the most suitable aircraft. Give a reason for your choice. Okay, now what is the objective? Okay, the objective is to find which aircraft can fly the fastest. Okay, which one will have the highest velocity? Okay, so we are given, as usual, we have four aspects that we need to look into. So we have mass, we have type of materials, we have power of engine, we have cross sections of the wings. Okay, so here is the aspect, correct? The first column is the aspect. Next is our selections or our choice. Okay, our choice or our selection, or I can also write here characteristic that I am looking at. Characteristic. And the last column, that would be for reason. Okay, if you don't want to write reason, you can also write here explanation. Okay, so aspect number one, okay, if you look at the table up here, aspect number one is mass. So we just copy it down. Okay, so the first aspect that we need to look into is the mass. Next is the type of material. Next is the power of engine. And lastly, the cross section of the wings. Okay, so let's do math first. Okay, if I go on the math, I only have two choices. It's either 6 or 8 times 10 to the power of 6. Alright, so which one do you choose for mass? So definitely we will choose 6.0 times 10 to the power of 6 kilogram. Okay, suppose you don't want to use the numbers, you can also write here low. Okay, choose low mass. So why do we choose low mass? Well, an aircraft, an aeroplane need to fly. Okay, so you don't want to have the aircraft to be very heavy. So why you need to have a lighter aircraft? So that it can fly. Okay, can fly more easily. This is common sense, right? Like I said before, this thing you can goreng, but make sure when you goreng, make it tasty. Okay, type of materials. Okay, what choices do we have? Okay, we also have two choices, iron or aluminum. So which one do you prefer? Which one is better, okay, for an aircraft? Iron and aluminum. So the best material, a better material would be aluminum. Okay, so here we are going to choose aluminum. Why do we choose aluminum? Aluminum, it do not rust. Okay, it doesn't, okay, does not rust. So if it doesn't rust, meaning to say it will last longer. Okay, for iron, definitely it will rust. It will react with oxygen, correct? Now, power of engine. Okay, power of engine, we also have two choices. It's either 1 or 2 times 10 to the power of 5 kilowatt. So for the power, you choose low power or high power. If I were you, I would say high power. Okay, so you can write here 2.0 times 10 to the power of 5 kilowatt, or I can write here high. Okay, so why do you choose high power? So reason, very simple reason, produce higher acceleration. Acceleration. Okay, next, What about the cross section of the wing? Okay, so you also have two choices. You have a rectangle here, okay, and here, what shape do we call this? Okay, this is streamline. Okay, so definitely we are going to choose streamline. Okay, suppose that you don't know the term to be used. Well, no problem. Just draw it. Okay. Uh, if you suddenly think of something else, maybe you want to write here aerodynamic. No problem. All right. But the best answer would be streamlines, or you can draw. Now, why do you choose streamline? Okay. Oh, sorry. Sorry for the wrong term that need to be used. It's not streamlines, but it is aerofoil. Right? Sorry. So here is aerofoil. Okay. What was I'm thinking just now of streamline? Okay. So the shape is aerofoil. Okay. For aeroplane, normally it's aerofoil. So why do we choose this shape? All right. The reason is it produces larger lift. Okay, so because we know the aeroplane need to take off, it need to fly. All right. Okay, so we have finished with the table. We are done with the table. Let's go back to the original table up here. So for the mass just now, we choose low, right? So I'm going to tick low here and low here. For type of material, just now we choose aluminum. Okay, so we tick aluminum. For the power of engine, we chose high. Okay, this one here. And then for the cross section of the wings, okay, we choose aerofoil here. So next, what do we do next? We count the number of tick. So for P, I have one tick. For Q, 1, 2, 3, 4. So Q, I have 4 ticks. For R, I have 1 tick. For S, I have 2 ticks. So which one has the most tick? Q. So we choose Q. Alright. So Q is chosen. Explain. Okay, so for the explanation, just repeat our characteristic, our choice, and then you combine it with the aspect. All right. So why do we choose Q? It has low mass. All right. So we are going to write here. The reason is it has low mass. Okay. Comma. Next, aluminum material. Okay, and then next it has high power of engine. And the last aspect, okay, and aerofoil wings. Okay, so that is the reason, right? So maybe I just erase this mistake just now. It's not streamline, but it is aerofoil. Okay, So we have finished discuss open book quiz 6. So we'll meet again next time. See you next time.